name is Stephanie, or Steph. You can call me all three. I'm going to be showing you 3 at-home science experiments that you can use with everyday materials in your own home. So I'm going to be showing you the materials you'll need, the science behind them, of course, and if there's any safety precautions you should be aware of. So I'm going to be showing you pretty simple experiments, and then I'm going to show you a little bit of a more complex one, but all of them are doable and they're going to be fun and are going to show you that science isn't that scary. It's actually pretty fun and it's all around us. So let's get started. This first experiment is called magic milk. So in terms of safety precautions, there isn't anything too dangerous with this experiment, but parental supervision is recommended. To take care of any spills, you're just going to be putting a garbage bag on a table, or you can also do this outside. So the things you'll need is some milk, optional plant-based milk, dish soap, and some food coloring. And you're also going to need a shallow bowl. So the first thing you're going to do is get some milk and put enough just to cover the bottom of the bowl. And then we're going to use some food coloring, any colors. I used my favorite colors, so they're neon, pink, purple, green, but any colors you may wish. And you can put any amount of food coloring. I put a few drops of each. Honestly, the more colors, the better with this experiment. So the way this experiment works is that milk is a mixture of fat, water, vitamins, and minerals, and when soap is added to the milk, it helps to separate the water and fat in milk. The soap molecules consist of a hydrophilic or water-loving end and a hydrophobic water-fearing end. And water molecules are polar molecules that can dissolve other polar molecules. And fat and oil molecules are nonpolar, so they cannot dissolve in water. So now that the soap is connected to the fat and water, the nonpolar fat molecules can be carried by the polar fat molecules. When we add the food coloring, the molecules get pushed around, resulting in this explosion of color. So the majority of the soap molecules attach to the fat molecules, and the soap spreads throughout the milk, and the color explosion will show and eventually stop. Now we're going to try and see if oat milk or any plant-based milk will work. You can try if almond milk will work or any types of milk that may have a little less fat in them, which helps with this experiment in particular. So you're going to be doing the same things. You're going to be putting food coloring, and you can also see right now that it's acting a little bit differently than when we put it in the regular milk. As you can see, it disperses a little bit more already. Think about why that may be. And then you're going to be putting a few drops of the dish soap, and you'll see the color explosion once again. Add more soap and see if there are more fat molecules that haven't attached to soap, and if there's unattached fat molecules still, the color explosion will begin again. And that's magic milk. This next experiment is a lava lamp. So in terms of safety precautions, it isn't too dangerous, but parental supervision is recommended. I'm also going to be putting a garbage bag on a table, or you can also do it outside, just in case there's any spills. You don't want them getting on your table or anything. So the things you'll need are some vegetable oil, a jar, some water, food coloring, and Alka-Seltzers. So the first thing you're going to do is you're going to fill more than halfway up the jar with the vegetable oil. So you'll see me doing that right now. And then you're going to get about 1/4 cup or less of water and put it into the jar. How does a lava lamp work? Okay, so there's 2 different things that make a lava lamp. There is polarity and there's density. So what is density? Density is how compact something is, how does it fit in a certain amount of space. So for example, water is more dense than oil, so it will sink to the bottom when two are put in the same container. Why is that? Because water molecules are packed more tightly. Density is also affected by temperature, so the hotter a liquid is, the less dense it's going to be. Polarity prevents the oil and water from mixing together. So as we can see here, the water molecules are not mixing with the oil molecules. We're now going to add some food coloring. So any colors you like, I picked pink, I picked purple, any colors that you want your lava lamp to have. So real lava lamps have a polar and non-polar liquid, just like our homemade one has. So water molecules are polar because they have an electrical charge that attracts other atoms. Water has two hydrogen atoms, which are positively charged, and an oxygen atom, which is negatively charged. So just like a magnet, these north poles are attracted to the south poles. So opposites attract. The positive end of water molecules will connect with the negative end of other molecules. However, oil molecules are nonpolar, so they do not have a negative or positive charge. So that's why they're not attracted to the water molecules at all. If we go back and talk about density, the denser liquid sinks to the bottom, but in a real lava lamp, the light heats it up until it expands and becomes less dense, causing it to rise upwards. And it gets farther from the light, it cools down, becoming more dense again until it sinks. Then the cycle starts over. So instead of a lamp, we're using this flat Mentos looking thing, which is an Alka-Seltzer. So Alka-Seltzer reacts with the water to produce carbon dioxide bubbles. So they stick to the water droplets, and this gas-water combo is less dense than the oil, so they rise to the top of the jar we have here. So now we can see it reacting and all those little bubbles rising to the top. So now we have a bunch of colorful bubbles. So we can see the purples and the pinks and the blues that I put in there. So at the top, these gas bubbles pop and escape into the air, allowing the dense water to sink back to the bottom again. And this will react for a couple minutes, so you can just observe and watch and see how those bubbles go down and up like a lava lamp does. I think one of my favorite parts is looking at the top and seeing all those colorful bubbles rise to the top. We have a shot here in the light, so you can see all the colors. This is after a few minutes of reacting. And you can see that more lava lamp looking effect. And that's a lava lamp. This next experiment is called a balloon rocket car. So again, the things you'll need: some little skewers, some straws, cardboard, some tape, 4 bottle caps with little holes in them, and some balloons. So in terms of safety precautions, there isn't many. Again, parental supervision is recommended. You don't even need this garbage bag, but if you want your space clean, then you can. The way that this experiment works is that the air in the balloon is under pressure, and the air pushes against the balloon, causing it to expand, and then the balloon is also pushing back on the air. And this relates to Newton's third law of motion. For every action, there's an equal and opposite reaction. So here we got a piece of cardboard, and then I cut the bendy end of the straw and put these straws and tape them onto the cardboard. Next thing I'm going to be getting is one of these skewers or wood dowels and pushing them through these straws. And then with the bottle caps that you've poked holes in, you're going to be putting these on these skewers. I recommend larger bottle caps because I think I've made the mistake of using pretty small bottle caps. I also had some problems putting these bottle caps through the skewers, so if you have the same problem, no worries. This is a little tricky. Then you're going to be getting a bendy straw, putting the balloon on the bendy straw, covering it, and then taping it around this area of the straw, and then taping the straw balloon combination on the cardboard, making sure that the bendy part of the straw is facing above the card. I'm demonstrating here kind of where you want the balloon to end once you put it onto the straw, and then using the tape to put it on the straw. You want to test out and see if you can blow air through the straw when it is taped to it. The balloon is taped to it, and see if you can blow air into the balloon. And then you are ready to drive. So, unfortunately, I was unable to successfully perform the experiment. This was my third and final try, and I was unable to demonstrate Newton's third law. But you guys are gonna have better luck than I will. So, this is just science sometimes. Thank you for joining me today and watching how these experiments work. I hope you try it out at home safely with your parents. This video just goes to show that simple materials in your home can lead to a science experiment, and also that science experiments don't go as planned sometimes, and that's okay. That's the beauty of science. Sometimes an experiment doesn't go as planned, and we look at what we did wrong and we can revise it. And that's learning. So I hope this video helped ease some fear from science and seeing how science is all around us, and you can do it too in the comfort of your own home. Thank you.